Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the chapter 9, areas of parallelogram and triangles, and start with the exercise 9.2. So let us start with the question number 3. The question number 3 says, P and Q are any two points lying on the sides DC and AD respectively of a parallelogram ABCD. Show that area of triangle APB is equal to area of triangle BQC. So we have to show that the area of triangle APB is equal to the area of triangle BQC. So let us start solving the question. In this question, a parallelogram has been given to us and they are saying that DC and AD are the sides of the parallelogram, and on those sides P and Q are any two points. So let us suppose on DC the point is P over here and on DC the point is Q. They are lying on these sides, and then they are saying they are forming triangles, and with P the triangle which is formed is APB, and with Q the triangle which is formed is BQC. So we have to prove that these two triangles are equal in area. Okay. So we will be applying here the theorem. So we will be starting the question by the theorem. A theorem says when a parallelogram and a triangle are on the same base and between the same parallels, then area of the triangle becomes the half of the area of the parallelogram. So let us take the parallelogram ABCD and APB. APB. Okay, so this parallelogram ABCD and the triangle APB, they are lying on the same base AB and they are between the same parallels. The meaning of the same parallels is that they should lie between the same height. So they are lying, the triangle also ends at this height, and the parallelogram is also having the DC as this height. This much height is of the parallelogram. So they are between the same parallels and they are lying on the same base AB. So the area of triangle APB will be equal to half of area of parallelogram ABCD. Okay. So let us mark this as equation number 1, and let us write down the reason according to the theorem. According to theorem, they are lying on the same base. And between same parallels AB and CD. Okay. Similarly, by taking the triangle BQC, so BQC and the parallelogram ABCD, they are lying on the same base BC. They are lying on the same base BC and between the same parallels BC and AD. Okay. So the area of the triangle BQC will be equal to half of the area of the parallelogram ABCD. Okay. So taking parallelogram ABCD and triangle BQC, and here also area of triangle BQC will be equal to half of area of parallelogram ABCD. The reason is same. They are lying on the same base BC and between the same parallels BC and AD. So let us write down the reason. Both are lying on same base BC and between same parallels BC and AD. Okay, so let us mark it as equation number 2. So from equation number 1 and 2 we can clearly see that the RHS is equal on both the sides. So when RHS is equal, the LHS will also be equal. So area of triangle APB will be equal to area of triangle BQC from 1 and 2, because on the right hand side it is being given that half of area of parallelogram ABCD is equal. Both the RHS are equal, so their LHS will also will be equal. Okay, so hence therefore from 1 and 2 triangle area of triangle APB will be equal to area of triangle BQC. Okay, and this only we have to prove. In the question it was asked to prove this only, and so we have proved it, hence proved. Okay, so let us move on to the question number 5, which says PQRS and ABRS are parallelograms and X is any point on the side BR. We have to show that, firstly we have to show that area of the parallelogram PQRS is equal to the area of parallelogram ABRS, and then in the second part we have to show that area of the triangle AXS is equal to half of area of parallelogram PQRS. So let us start with the first part. In the first part we have to show that the area of parallelogram PQRS is equal to area of ABRS. So the area will be same according to the theorem. There is a theorem in this chapter which says if both the parallelograms are on the same base and between the same heights, then their area will be equal. So just we have to write it down according to the theorem. So the first part, area of parallelogram PQRS will be equal to area of ABRS according to the theorem. According to the theorem, if two parallelograms are on the same base and between the same parallels, then their areas are equal. Okay, so here the same base is same SR. Let us mark it down. Same base SR and between the same parallels, and the parallels are SR and PB. Okay, so the same base, so both of them are on the same base. PQRS is having the base SR, as well as the parallelogram ABRS is also having the base SR, and they are between the same parallels SR and PB. So we can say that the areas are equal, hence proved. Okay, hence proved. Now in the second part, we have to prove that area of the triangle AXS is equal to half of PQRS. So we can clearly see that the triangle is on the parallelogram ABRS. So let us mark it as equation number 1. Okay. So the triangle AXS and the parallelogram ABRS, they are on the same base AS and between the same height AS and BR. So the area of the triangle AXS will be half of area of the parallelogram ABRS. Okay, so let us taking triangle AXS and parallelogram ABRS. Okay, so it is clearly seen that they are on the same base AS. So area of triangle AXS is equal to half of area of parallelogram ABRS. Okay, let us mark it as equation number 2. We can write it down the reason. Clearly we can write it down the reason, because both are lying on the same base. Both are lying on the same base AS and between the same parallels AS and BR. Okay, so this is our equation number 1. This is our equation number 2. So from equation 1 and 2, we can clearly see that the areas are equal. So we can replace this parallelogram with the parallelogram of area PQRS from equation 1 and 2. Okay, so from equation 1 and 2, we can clearly say that area of triangle AXS is equal to half of area of parallelogram ABRS. Okay, and it is equal to half of area of parallelogram PQRS. Okay, and if we consider these two terms, then what we have to prove is already been proved over here. Okay, we have to prove that area of triangle AXS is equals to half of area of PQRS. So area of triangle AXS is equal to half of area of parallelogram PQRS. Okay, so this was only thing which we have to prove. This was the only thing which we have to prove in this. So in these questions we have to apply the theorems. The theorem says if two parallelograms are on the same base and between the same height, then their areas will be equal. But if a triangle and a parallelogram are on the same base and between the same height, then the area of triangle will be equal to half of the area of the parallelogram. Okay, so with this concept only we solved the questions. So hence proved. In this manner only you have to solve the rest of the questions of this exercise. Okay, so thank you. So please subscribe my channel and also share my videos. And if you have any doubt, you can ask me in the comment section. Thank you.